All right, today's lesson, today's video is going to be over learning target 2 for linear equations and inequalities. We're graphing and solving inequalities that contain absolute values. This is going to be kind of a fast run through on the notes, so if you need to, make sure you pause this, rewind it as you need. First, the absolute value of x is less than or equal to 3. Literally, that means what numbers for x are less than or equal to 3 units away from 0. So if we had a number line labeled from 0 to 3, we would definitely shade towards 3 because they're less than or equal to 3 units. We'd also shade towards negative 3. And because it says less than or equal to, those values of 3 and negative 3 are included, so we use closed circle. And if you remember from learning target 1, that kind of looks like an and answer. So when we are working with absolute value inequalities and we have a less than or equal to, we will use the word and. So anytime there's a less than or equal to, we'll use the word and. And the left side of these notes are all dedicated to and problems. The right side is dedicated to greater than, which will be or problems. But let's think about the definition of the absolute value of x. It's literally saying what numbers x are greater than 2 units from 0. So if we had 0 on the number line, we wouldn't shade anything until we get to 2. And then we would start shading numbers greater than 2 units away from 0. We would also not shade on the left side of 0 until we get to negative 2. And then we would start shading to the left forever. Because it says greater than 2 units from 0, we wouldn't actually count the 2. So we put an open circle at 2, and we put an open circle at the negative 2. Still got to work on my drawing on my smart notebook, that's for sure. But what kind of answer does that look like from learning target 1? It looks like the whisker shading looks kind of like an or answer. And they are going to always be or problems when we have a greater than inequality for absolute values. We also have templates for case 1 and case 2, for these inequalities. I'll remind you from Algebra 1, when you had the absolute value of a equals b, case 1 was a equals b, case 2 was a equals negative b. It's very similar in Algebra 2 with inequalities. If you have less than or equal to, your case 1 will be a is less than or equal to b, and your case 2 will be a is greater than or equal to negative b. I guess kind of one way to memorize or remember this is when you take when you have negative b, kind of think of dividing by a negative to make that opposite b, so you have to flip the sign. So if it was a less than, you change it to greater than. And the word that goes between the two cases is and. Similarly, over here on the right side, the right column, if you have an absolute value that is greater than or equal to b, the first case will be a is greater than or equal to b. So whatever's in the absolute value is greater than or equal to b. Then the word will be or between the two. In the second case, flip the inequality, change the b to negative. All right, so now I've got two examples for us to follow. In Algebra 1, you were told that you needed to isolate the absolute value before doing case 1 and case 2. That is still true in Algebra 2, isolate the absolute value. In example 1, there's nothing in front of the absolute value, and there's nothing after the absolute value on the left side of the inequality, so it is isolated. In example 2, there's a negative 3 in front of the absolute value. Be careful, it kind of is tempting to distribute that negative 3, but there is no distributive property for absolute values, so we can't distribute that negative 3. So according to step 1, if we need to isolate the absolute value, we're going to need to get rid of that negative 3. And the way we do that is use the division property of inequalities, which says you can divide whatever you want to both sides. But if you divide by a negative to both sides, I'm sure you remember as soon as you heard me say that divide by a negative, you're going to need to flip that less than and make it greater than or equal to. And then negative 9 divided by negative 3 becomes 3. So that would be step 1 for both of these two examples. Step 2, look at the inequality next to the absolute value and determine whether it's an and or an or. So in example 1, it's a less than. According to our notes up here, less thans will always be an and. So we'll put an and out here. I guess I need to decide capitals or lowercase. We'll put an and there. And according to step 3, we're going to use the formula to make case 1 and case 2. So for example, case 1, the formulas I'm referring to are these templates, if you will. In example 1, we're following the less than template. It says take what's in the absolute value and make it less than b. Make it less than what's on the other side. So in the example 1, x plus 2 is our a value, and 5 is our b value, so it's less than 5. Case 2 will be x plus 2, that's the same a, but now flip the inequality, so make it not less than, make it greater than, and change the 5 to negative 5. That would be the opposite of b. And from here on, it's learning target 1. Subtract 2, x is less than 3. Subtract 2, x is greater than negative 7, and the word is and. So I'm not going to graph this and do union notation and set builder notation, all of which you are required to do on the homework. If you need review on that, you need to look back at the Learning Target 1 notes, because the rest of this would be Learning Target 1. Example 2, we already did step 1. We isolated the absolute value. Now, step 2, look at the inequality. It's a greater than now. So according to our notes up here, greater thans are always ors. So we'll put an or in the middle of our two cases. And our two cases will be, for this greater than problem, case 1 will be 2x plus 1 is greater than or equal to 3, or 2x plus 1 is, switch the sign, less than or equal to negative 3. So I'll write those two down that we just said. 2x plus 1 is greater than or equal to 3, or 2x plus 1 is less than or equal to negative 3. The rest of this is learning target 1, but I'll at least subtract the 1. 2x is greater than or equal to 2. Divide by 2. Or subtract 1 over here. You get 2x is less than or equal to negative 4. Divide by 2. X is less than or equal to negative 2. And then you'd need to graph that on a number line, do union notation and set builder notation. What I've been referring to as union notation is also referred to as interval notation. So when you're doing Math Excel, remember that. But that's the end of the notes for Learning Target 2. If you have any questions, you're welcome to come into tutoring from 7 to 8 o'clock any morning. But make sure you're always watching these videos first. So that will do it.